So Steve and Linda, I don't know who wants to fight to come up first, but I'd like to, Stephen's got the place. Stephen from ICRC wants to have a welcome. Thank you.
I know Vanessa's very strict on the time. I've got 3 minutes. Let's move it. Mom, I'll pick up the groceries after this event if you're online. Thanks very much, everybody. And thank you, Cape Town, for hosting. It's always great to show Africa and the wonderful destinations for events. So it's really, really good to be here. On behalf of the ICRC, I really want to thank UNODC and DNA for Africa. It's not just this event that we're partners. We collaborate on a number of different initiatives. So it's so important for us to show this collaboration and really appreciate what the partnership will do in terms of broadening our networks, helping one another with expertise. So this is a really, really great relationship. So thank you to you both. I want to thank Thermo Fisher, who is a sponsor, but we've got to know them through Vanessa, and it's been an amazing relationship, and you're always there helping us along. I want to thank, I think there were 383 participants registered last night. I hope they're all actually participating, but thank you for making your time, giving us your time over the next 2 days. I want to thank the international speakers, and there are some international speakers that actually have paid their own way. They weren't sponsored. They've come here with their own money to make sure that they're part of Africa and what Africa is actually offering. And it's not just to Africa. This is an international event. There's participants online from everywhere. I definitely want to recognize the African expertise. We are able to hold this because we have such tremendous expertise on this continent, and we really need to show this off. So these are great platforms for us to show the wealth of expertise here on our continent and to really show off what we got. Like, let's be proud of what we have right here on our doorstep. Science, law, humanity, it couldn't be more important to the International Committee of the Red Cross. We are dealing in areas of conflict. We watch the suffering from migration. We see disasters every day. Our people are we're really in ground zero. We're seeing people die every day in conflict, combatants, non-combatants. We're seeing horrible inhumanity and torture and death in detention centers. We see sexual violence every day in conflict. There are so many different scenarios where we're using forensic sciences today. And thank God for people like you who can actually improve and advance the science so that we can improve the lives and reduce the suffering of those people that are in those situations. So I thank you for being here today. It's really important that we learn as sort of the people who keep promoting forensic action, humanitarian forensic action. It's so important that we take the expertise from you and share it out there into the communities. It's one of the important elements for us is we're very interested in building a systematic response. Our organizations have different mandates, but our affected populations are the same. We've got women who are affected through violence and through sexual violence in conflict areas. That affects UNODC, that impacts the ICRC. These people need our support. So this is not just about criminal investigations, but very much about how we deal with the victims, the families, and the communities in these types of situations. I hope that this is just another opportunity for you to become part of the African forensic community. I know Vanessa has her Forensic Fridays, which I hope you read. She does question. She will have a little quiz, I guarantee it. But we also have an African forensic community with the ICRC. If you want to be part of that, if you want to know what other events are coming up, please come and talk to me. I'll give you my card. You just send me your email address and you can become part of this community. Let's make this African community huge. Let's become more noticeable internationally so we can get more funding onto the continent and support programs. I welcome you again. I'm grateful to my ICRC management for supporting this and allowing us to participate. Again, thank you UNODC, thank you DNA for Africa, but thanks Linda and Vanessa for dealing with myself and our bureaucracies and all of the issues that we have to deal with internally. But I hope you have a wonderful event. Thank you so much for being here. And I look forward to hopefully meeting a lot more people today. All the best to you. Thank you.
the beauty of having two amazing speakers before me, I can say all of the above. But a very good morning to all of you and welcome and to this African-wide DNA Symposium, but also, like Stephen says, global event. And I'm absolutely delighted to render these remarks on behalf of the UNODC regional representative, Ms. Jane Marie Ngolo. And I want to say that this epic event has been a wholesome construction and remarkable synergy between the three organizations, DNA for Africa and really the International Committee of the Red Cross and the United Nations Office on Drugs and Crime. So my heartfelt gratitude to our partners, Stephen and Vanessa, and to the amazing teams that have supported this joint venture. This innovative process has been so well connected and will show how science can serve humanity and justice. And we have in our room so many, too many to mention, are highly acclaimed speakers from all over the world. And they need little introduction, really. And they've been carefully selected by the team. And I have to mention a name that you all know, Professor Bruce Badal. And you've all heard him before, and I'm sure you still want to hear so much more from him. So esteemed participants, thank you for so positively responding to the invitation to participate online and in person. We really appreciate how we can work together in this rich, eventful occasion. And ladies and gentlemen, really, we need to take cognizance, within the African continent, but globally, the high prevalence of gender-based violence and that exists. And, gender-based violence targets or affects women and girls in very high proportions throughout the world. And we know from research, 1 in 3 women are affected by gender-based violence throughout the globe. And according to research that has been done by UNODC, the official data says that Africa is a continent where women are most likely to be killed by their partners or by their families. So we need to change that scenario. We need to look what we can do differently. Crimes involving violence against women are among the most underreported and least likely to end in conviction. Survivors often face significant obstacles due to gaps in criminal justice practices, their law, the stereotypes that they experience, the victim blaming that they've been exposed to, and also the inadequate responses from the multi-sectoral team, ultimately leading to secondary victimization. And even when survivors do report, they often face multiple challenges to justice. The lack of access to critical services, delays reporting, and the insufficient evidence to convict are just some of the reasons why perpetrators of violence walk free. We need to hold perpetrators of sexual violence accountable. And one of those processes involve improving the capacity to collaborate, collect, analyze, and present forensic evidence, and also importantly, interpret that forensic evidence in the criminal proceedings. When the criminal justice system fails to fulfill women's human rights, this contributes in perpetuating cultures of invisibility and impunity. This impunity, which is an exemption from punishment and accountability, fuels increased violence against women. It is especially encouraging that the UN has a new agenda, Agenda 2030, and really focuses on how we can address violence against women. Factually, gender-based violence offenses are often committed in private settings and without any witnesses. DNA evidence can be used in gender-based violence cases as a silence witness. Every person has a unique DNA profile, so it can be used to accurately identify and convict a perpetrator. The use of forensic DNA evidence in gender-based violence cases help to identify suspects even in the absence of corroborative evidence, and can increase the resolution of criminal cases and achieve justice for survivors of sexual assault. DNA profiling is an effective investigative tool to be used within the wider context of all other evidence in a case. So DNA evidence helps build that case against the perpetrator, increasing the likelihood of holding perpetrators accountable, but importantly, prevents future sexual assaults from occurring. We need to change our approach in the way cases of gender-based violence are handled, investigated, evidence is generated and presented. And I do hope that this symposium offers an opportunity to engage on these key issues. This event will certainly offer a platform for interaction, sharing of skills, a robust discussion, knowledge, and sharing of best practices. So, ladies and gentlemen, I look forward to the outcomes of this event, and I am most assured that it will be a game changer, not only for the African context, but for the global community. With that, I thank you.
Thanks, Linda. I think you can see from our three personalities how things go down. In any meeting, I'm, oh my God, I'm going to do this. Stephen always has a sense of humor, and Linda's like, dearest Vanessa, are you okay? Am I right? But the partnership works. We somehow found our way. Thank you so much, Linda, and thank you so much, Stephen. So let's get the day started. And up first is Professor Bruce Bedoley. And as we all know, Bruce is, your reputation precedes you, Bruce. You are, as I said, one of the most published forensic scientists in the world. It's such an honor that you give of your time so freely and openly to all that you meet. And I know that even, albeit we've spent all day yesterday with you, that you're going to enlighten us even further this morning. So I'm just going to give the stage right over to you so I don't take any of your time, because I know that you like every single minute. And let's welcome Professor Bruce Bedoley back to stage.
Yeah, you can hear me? Okay. Well, thank you. I was given the task by Vanessa, surprise, okay, to talk about scientific solutions for complex DNA cases. And she said one thing: don't make it technical. And of course, if you have science, you have to have technical things. So if I talk about technical things, the scientists in the room are going to say, that's really cool, that's really nice. The people who are the lawyers, the administrators, these things, they're going to say, what the heck did he say, right? So we're going to kind of balance between these two worlds as best as we can. I can't possibly talk about all the solutions, so I've just picked a few across a range of scenarios we do. Part of what solutions are is making a prediction of the future. And predicting the future is very uncertain. And this is an example of a 1954 publication of what the home computer would look like in the year 2004. It may be not quite the same as it actually turned out, because there weren't advances like the computer chip that was there until subsequent to that time. So what we think might be the solution may not be what it actually turns out to be, because innovation is occurring all the time, and there's always going to be ways to handle it. So we are in forensic science, and we are trying to use scientific information to serve as another eyewitness to help reconstruct crimes, and of course, hopefully towards the truth and justice to be able to serve them in that. It's objective, but our goal in DNA is attribution. Who is the source of the sample? Whether a crime was committed or not, that's other data often that has to be collected along with it. So we shouldn't think about DNA proving the act has occurred. There are a lot of different areas that DNA can be quite helpful. Some of them you work in, some we are, you may address in other ways. but they all are valuable for the identity of an individual. To determine what we should talk about in a complex case, we first have to think about what is complex. And that can be quite different. It can be at the crime scene. You have a chaotic environment. What do I collect? How do I collect it well? Could be transporting it from the crime scene that might be in a remote area to the crime lab. That could create complexity in that. Of course, all the things we think about with DNA of low quantity, low quality DNA. And then afterward, another complex challenge is how do I convey what I found with its strengths and its limitations to another part of the process, the judicial system or the investigators in the process. So they're all quite complex. And so to do that, we think of, as scientists, we think of technology. Now we're starting to think about information analysis. Is there more that I can glean or better ways to glean information that could be helpful in reconstructing what happened in a case? We have to be transparent about it because when we're not, we actually create complexity as well. And as I said, we have to communicate it through educating and training people. If you think about it, you go to court and you're going to educate a judge, or in our case, a jury, in 30 minutes for something that took you years to learn. You're not going to be able to educate them well. You're going to have to communicate something to convince that individual that what you say they should consider as reliable, valid, and so forth. And of course, collaboration can help in the process. So I mentioned that it could be anywhere from the crime scene to the courtroom that we might want to think about. One way to think about it is the processing of DNA. We're going to start with the crime scene because we often don't think about it. We get caught up in this whole area in here of extracting DNA and typing DNA and informatics, and we forget about the most important part of it is if you don't collect good evidence, you don't get good results. So garbage in, garbage out. And so I thought we'd spend a little time on that and just talk about, sometimes we can have simple solutions. Some of the work we did was just with swabs. There are a lot of different swabs, and I find the swab that is most chosen is the cheapest one. Yeah, it makes sense, right? It's cheap, I'm going to spend money and that. But there are other swabs, such as nylon swabs, that have a better design that may be helpful. So when we think about cotton swabs, they are really great collectors. They collect DNA, biological evidence well. But when you try to extract it, they don't release it well. So while it's a good collector, it's not a good releaser. So yes, it's cheaper, but are we getting what we need? And if you think about, I'm going to spend, let's say, 10 Rand on a swab. I don't know if that's what they cost, but 10 Rand on a swab or 100 Rand on a swab. If you're not getting enough DNA back, it's not really cheaper. It's actually more costly if it doesn't work. The nylon swab has a better design because it'll release what it collects because of the nature of the structure. And so we've done studies on these to increase yield. We've also looked at microflux swabs. So if you collect a stain, one of the problems we have, and we'll talk more about it, is, or any sample you collect, do you know if there's any DNA on that swab? Think of a firearms, which is something you think about throughout Africa, as we do in the US. You swab something, it's invisible. Is there any DNA on that? So I have to go through an extraction, a quantification, or a typing to get a result. I spend a lot of money and resource. If I could subsample the thing and see if there's enough DNA on that without really taking much from the sample itself, I could have an advantage in my processing and show you that you can get, with dilutions of saliva, really good profiles. And you can get it from all sorts of different sources, even though you would think this small quantity wouldn't be sufficient. One of the things to improve or reduce the complexity is to get better results. So when people look at stains or whatever in the process, they tend to sample without thinking about where to sample in the stain. And so when you make a stain or you collect something, it turns out that the edge of the stains, as you might predict, if you understand the dynamics of stain deposition, has more cells and DNA on it than the center. So if you're sampling in the center, because everybody thinks that's the best place to go, you're getting less yield. So we can improve our processes just by sampling better strategies on how stains develop in that. Because the cells hit, they start to migrate out, and then they get captured. So the edge is better, and this is just showing example of center and edge, and you can't tell, but the scale on this is such that these are much higher peaks than over here, just from the simple thing. Well, that also presents us with complex mixtures. When we sample something, we take something from a stain, and we might get a 4-person mixture. But a stain isn't all people deposited homogeneously throughout the stain. Sometimes sampling in different areas can get you components of that stain. So you could think logically is that maybe I just don't want to do a one cut and done, or if I cut once and I get 4 people, 3 people, maybe I'll cut somewhere else and see if I can get 2 or 1 and help in that. So that's another way we can improve the process. One of the advances that we've been working on over the past few years is dealing with this invisible DNA, which is much of the work we see these days, is that something's been touched. I don't know if I got DNA. As I said, we have to go through a process. We can use fluorescent technology to determine if we have DNA in our swab. And if we have the DNA, then we can decide to move forward if it fluoresces enough to go on to extraction. So we're not blind anymore, and we can make more judicious decisions, use less resources, and be better in our processing in that. So it's, there have been reports on that in the literature. One problem with fluorescence, everything fluoresces. Swabs fluoresce. The background material fluoresces. So you can't get to the sensitivity of detection if something is fluorescing because it blanches out your signal. So it's desirable to develop better methods. And I'll just quickly get to the end here because of the amount of time I have. There are technologies that take advantage of intercalating dyes that help DNA to be visualized, and what we'll call a pulse generation on that, separating the background from the excitation that we'll see from the intercalated DNA, such that the swabs don't fluoresce anymore. And all we have is the background, so we get the picogram level detection. So just by taking a swab, putting it under a light source and recording, it is going to be feasible in the very near future to be able to determine that without having to go through all these processes. So that's part of the future. So capillary electrophoresis is our mainstay. It works well, and we probably will still see some improvements in that area, but this is a value to everybody because you can reduce complexity by exchanging information. If I see something in my lab that doesn't work right, I often don't say anything about it because I don't want the defense community to know what's going on. But at the same time, all my colleagues don't know what's going on. You have to really start thinking about the exchange of information so the problems that one lab sees, the other gains benefit from, improve the process. Although it's a great tool, it doesn't solve all our problems, and there may be additional ways that we can improve on our process, coming up with better ideas, and some we've already mentioned already. And rapid DNA is one that has a place as well. Still capillary electrophoresis. But if you had a mass disaster, say out in the hinterland, you can't move the lab there, and you're not going to be able to get all the samples. If I can move the lab to the scene, I can get samples typed before things degrade, decompose, or they get mucked up. That can improve my process. And the idea is moving all the steps into one box to move forward. So it has the place as well. And I'm going quickly because she's going to yank me off the stage before we know it. And, you know, it shows that it can work and give you signals and so forth. And we know there's an agency in the US that solved their complex issue, which was the backlog in the government lab. There was a backlog, couldn't get the work done that they needed. So by having this, they were able to address their needs locally in moving forward. Back in the early 2000s, something changed. The Human Genome Project cost $3 billion, took a decade to sequence one human genome. Again, not going to be, as I said yesterday, not going to be something you're going to do in the crime lab, but the Human Genome Project did something else. It built an infrastructure to promote innovation. And technology changed so that the cost has been dropping dramatically over the years, where a $3 billion genome is no longer a target site, but a $100 genome is now becoming a reality. So we're seeing a lot of advances in that. One of the advances they made many predictions, but one of them they didn't really predict about is the advances in forensic science. So with massively parallel sequencing, the innovation that occurred around 2005, 6, 7, you can do the same kind of work that took a decade on your desktop. So now you have the chance to interrogate far more data to answer more challenging questions than we could ever do beforehand. And there is a value in this technology compared to the current technology, and that is one protocol does everything. So if you can type STRs, you're going to use the same protocol to do mitochondria, same protocol to do SNPs, where under the current system, we need different protocols to process and get the samples ready. So that complicates labs, and many labs don't want to have multiple markers because it's too much work. It's too much challenge. Now, it doesn't matter what it is I'm doing, I can get it done with the same system. There is a challenge. You generate a lot of data. So in the past, where I would look at every single marker in the profile and make a judgment, it may not be possible to look at 1 million SNPs at one time. In fact, it is impossible to look at 1 million SNPs at one time. So we're going to have to rely on large amounts of data to do that. And so bioinformatics is going to become a critical part. This already presents a challenge to the crime lab because you don't have bioinformaticians in the lab, and you relied on in the past, you relied on software solutions. So one of the challenges is to develop software that could take a sample, give you an answer in a simple, flexible manner. That's what we want. When you do CE, there's a lot of bioinformatics being done on that you don't see. You get a profile that you've been trained to interpret. So how do we get to that same stage here is the next step. And we can do that with an example with mitochondrial DNA. This is the most successful typing marker, especially in human remains, because of the highly degraded sample or the hair shaft, because there's limited nuclear DNA that's typable within the hair shaft. Test. A lot of labs don't do it. It's a lot of work, but it's quite valuable. And if you do sequencing, one of the things I've heard with mitochondria prior to sequencing is, well, it doesn't give you a lot of information, which is a misunderstanding of the value of mitochondrial DNA, because it can give a lot of information. However, by sequencing, we find that 75% of the total genetic variation is in the coding region, which isn't typically sequenced by Sanger sequencing. Going to whole genome sequencing, we get 3 times more information than we would get if we had just done it by the traditional method. More than that is, traditional method consumes 4 times as much sample and requires 8 times as much work. So by doing this, we only do 2 amplifications and we sequence it all at once. In the traditional method, we do 4 amplifications, typically for a forensic sample or more, and we have to sequence them both in forward and reverse strands. So that becomes another challenge, one that we can reduce. And then the unknown secret, or the little secret that most people know, so it's not a secret, I guess, is heteroplasmy is much of a challenge. And in traditional sequencing, you sequence all the molecules at once, so heteroplasmy confuses that because you get out of sync when you have like a linked heteroplasmic garbled signal. But with massively parallel sequencing, each molecule is individually sequenced. So you don't have that anymore, and you can now actually see all the variants as they are, so nothing's garbled. So another value in the process as well. It's very sensitive. This is a 1 centimeter hair shaft giving results. And the other value is it's quantitative. So mitochondrial DNA, although it's very powerful, it's only used on single source samples because it wasn't quantitative. So if you had a mixture, you might get confused on what is a major or minor. But I color-coded the 3 variants, the SNP sites, for this mixture. And as you can see, it's about a 3-to-1 ratio. So you can tell which one is associated with this individual based on the quantity alone. So now we have another tool that we can use in mixture work as well. For capillary electrophoresis, we have to design our STRs in a way that they can parse out across the real estate of the separation. So some amplicons are small, some have to be large within one dye channel. So this limits as well what we can do in typing. This is a good system, but those that are in the large amplicons are more likely to degrade than those who are in the small amplicons. So with challenge samples, we're going to get partial information or no information because we're going to be sacrificing these by design. But by sequencing, we're no longer bound by this because we're now using the sequence to identify the marker. So we can now change and move the amplicons to smaller sizes and more equal in size. That has two advantages, well, several advantages. One is better for degraded samples, more similar efficiency in amplification, and you get better product when you have smaller amplicons than larger amplicons. So all those have a value in the process. The other value is that you can get sequence information, not just length-based information. So when we run by capillary electrophoresis, we say it's an allele 14. We don't know if it's a 14. We just know it's the same size as a 14, and we call it a 14 based on some reference standard. And that's perfectly okay, but underneath it might be a 13 and an insertion somewhere, or it could be a variant somewhere in the process. So we don't get all the information we would like. And in simple population studies, we find you get twice as many alleles, whether it's autosomal X, Y STRs, that could be used for interpretation and discrimination of individuals. So that improves our process. Here's an example of one locus. This would be the frequencies of the different alleles in a population if we were doing capillary electrophoresis. Some of these alleles are different alleles, all the same size. These are the number of alleles and their frequencies, which are obviously all much less than they are here. So we've already improved our discrimination power just by using another method. You can actually search for better markers. None of the STRs that we use today were selected for sequence variation because we didn't have the tools to determine that. So we did a study to say, okay, let's search the genome and find STRs who have sequence variation and some other characteristics. And so we have the standard core set of the CODIS markers, the 20 or so. And then we had the 20 that we determined that would be far more informative. And then we took the best of those, and 3 of them in the CODIS actually are really good for sequence, discrimination power based on sequence. And basically what it says is, if you do length, the best way to tell if you have a good discriminating system is to look at mixtures. If I take 2 people and I have a mixture, if I have complete discrimination between them, I should see 4 alleles, 2 from each of the individuals. Anytime I have less than 4, it's not fully resolving them for whatever reasons. Either they're homozygotes or they share alleles or whatever it may be. So you can do that in silico, take profiles and mix them together and see how often I see 4 alleles, 3 alleles, and so forth. And so out of the 20 loci, if I used capillary electrophoresis and the standard core markers, I on average will see 4 to 5 loci with 4 alleles. So the vast majority of them are less than 4 alleles. If I use the sequence data, I'm up to around 15 of the loci would have 4 alleles. So I've already improved my ability to differentiate during mixture interpretation. To show you how it would work and what value could be, here is a construct of a mixture. I'm telling you up front, it's of 2 people who are 11 and 12. So they both have the same genotype. So what am I going to do? From this perspective, one person could be a homozygote 11, one could be a 12, one could be an 11-12 and an 11 homozygote, or some other possible combinations. That means I have more uncertainty in describing who are the contributors or their types, or they're contributing to this evidence. The more uncertainty, the more possibilities, the statistical power becomes lower. I can't get as much power out of it if I had only one explanation. And now color-coded it to show what would happen in an actual case. the two individuals share an 11. They have the same sequence, so really don't get much from that. However, they have a different sequence at their 12. And we can see now that we've got sort of a 4-to-1, 3-to-1 ratio of the individuals. So right away, I already know something about the proportions. And given that we have, with a smaller contribution, some stochastic effects, it would make sense that this difference here could be due just to a lower level, and that the best explanation is an 11-12 for both individuals. So I've improved my ability to interpret complex evidence because I have more information in the sequence. We talked a little bit yesterday, so I'll go quickly. One of the real values that has improved our process is the most difficult part of forensic analyses, which is mixture interpretation, sort of what we just talked about to some degree. Improving on the technology end is really the best way to go forward. But as we go forward, we still need to improve on the interpretation end. And typically what would be done is we would set a line in the sand, a threshold, and we'd say, when it hits a certain point, everything is reliable, and when it goes below that, it may be uncertain. And that could be just one RFU difference when you have a line in the sand. But logically, that doesn't make sense that one RFU difference should really have such an impact. So we've gone from this approach where we look at a profile and we say, well, these two major alleles, the 13, 15, come from the major, and then the 12 and 14 come from the minor, because that's what our brain tells us is a good answer, to, well, you know, these are kind of low-level samples, and maybe there is a possibility that this isn't the only answer. And so through some mechanisms known as probabilistic genotyping, we can determine that by using an unknown space to try to, by guessing many times, to get to a point where every guess we have is assessed whether it better explains evidence or not, and taking many guesses to where we can get to the final one. So getting from here to here wasn't that many steps. The number of guesses was many. And with the power of the computer, I can guess and guess and guess, and eventually I'll get to where I need to be because I guessed many times till I got something that better explained the evidence. And this has been a real boon to mixture interpretation, to where complex patterns presented in mixture evidence that would have been inconclusive by manual means now can be portioned out and given different probable explanations for the genetic evidence. That's going to improve what we do a lot. Databases are important. They have been another boon to the work we do because we can put profiles into a database, and I'll talk about CODIS because I helped start CODIS. I know it better than others. And I mentioned one thing, it's free, which also is a nice feature, right? Right, yeah. Okay, and then we search those profiles to get investigative leads from evidence and such. So that's another powerful tool for us. And the idea is we're putting profiles in the database from known individuals to solve or help solve future crime. And typically it's done where we have an evidence sample, or the way you do it in South Africa, you have a direct match and I guess high stringency of profile to profile. Not all evidence will give you a full profile. You get partial, and that can complicate the work you do. So we can use other methods, and I talked a little bit yesterday about it, called genetic genealogy approaches. So everybody, was anybody not there yesterday? Okay, one or so. You don't count. No. Okay. So anyway, we were just going to quickly go with, just mention quickly, we talked about familial searching, YSTRs, and dense SNPs to solve these problems with the different cases we mentioned, and the challenge with kinship, where we don't know if we have that or half SIBs. So depending on the sharing of alleles or not, we could be compromised in the power of the test. So we went on to the Golden State Killer case, the dense SNP profiles, by looking at shared amounts of DNA with individuals. I want to skip that because we talked about it yesterday and the power and the benefits of it, and talk about other things for complex cases. I mentioned yesterday that you might be able to use it to solve molecular autopsy cases and such as autopsy cases where all the evidence doesn't help you, so you keep drilling down and down. We know that depending on our genetic makeup, our stage in life, and our exposure, that we are going to have situations that could put us under stress and be a triggering event that could end up killing us. An example I had was the 13-day-old infant who died of morphine poisoning that began a criminal investigation because infants don't go out and get drugs on their own. And it turned out that the mother was an ultra-metabolizer for codeine, and that was that she was metabolizing or codeine into toxic levels of morphine, breastfeeding it to her infant, and died changing that. So that would be there. The last thing I want to mention, because I want to get to the last part, and then I'm getting kicked off the stage, is enhancing training, because we do all this work and then we go to the judges and the lawyers and they don't understand it, so they ignore it. Or to the police, who you give them a report that you have a hit in a database and they ignore it because they don't know what it is. So we have to start thinking of ways to get this information that we have into an understandable level for the people that we are actually providing the information for, the handoff for the next part of the process. So I want to stress that there are tools out there like virtual reality training where we can put the whole process into a headset, and the prices have dropped dramatically. Not the new Apple one, that one's really expensive, but the general ones like you can get from Google and such, fairly cheap, cheaper than phones these days. And you can put all the protocols in and have people manipulate with it, so you can learn and get your muscle memory by doing this work. And then when you're better trained, then go to the lab so you can save on the cost of reagents and instrumentation, and that can get people trained. The other value is the trainers can be training everybody. So when I train someone on population genetics, I'm really surprised how that person I trained now trains the next person, who then trains the next person. By the time you get to the end, the 5-day course is 15 minutes on this is all you need to know. And so we lose a lot if we don't have that. So we can standardize the training and everybody can be exposed to the same kind of work. And you can have all sorts of things from human trafficking events, fundamentals of DNA, and so forth. And although it seems expensive, it's actually quite cost effective because we're getting this value of training to all different sectors at the level they need. And I'm going to stop there and not talk about all the tree of death or anything else, and just acknowledge everybody and thank them all for allowing me to be here today and give you just a taste of a little bit of what we can do. Thank you.
Thank you, Bruce. I know we can listen to you all day. I asked Dino in the back, what slide are we on? He said 30 of 102. Okay, because there's just such a wealth of knowledge that Bruce brings to the table, and we almost need a whole nother day with you. So I think next time we need to plan for a 2-day workshop to get through everything, and then a 2-day symposium. So thanks as always. There will be a panel at 10 a.m., which is going to be all about the challenges of highly degraded and complex samples, and we'll be able to ask Bruce more questions there together with his amazing panelists. And just to let you know, your lanyard has a pocket on it. There's a QR code there. If you scan it, has the full program. So all the bios are there, the abstracts for every single presentation. And for our online audience, just go to dnaforafrica.com, and you'll see the full agenda button, which you can download. So we don't have to waste too much time going into everyone's full bios and abstracts. You'll be able to preempt it and read them there. So I'm going to introduce Dr. Catherine Smith, who's our next speaker. Catherine and I met at the end of our doctorates. We were in the throes of the last few months when you start to get those eyes, although I think you were a lot calmer than I was. And we understand this concept of personhood, which is something that we both believe in quite strongly, and you're going to hear a little bit more about it hopefully today. But Catherine and I then finally met, because that was in COVID in person in Kigali, where I had the privilege of listening to her presentation there. And it was absolutely fascinating. She really has broken the frontiers of forensic science, which you'll hear about soon. Catherine's actually an interdisciplinary visual and forensic artist who's found herself in the world of science. and her expertise lies at the convergence of art and forensic science, making her literally a pioneer in her field. And she serves as the chair of the Department of Stellenbosch University, and I'm sure you bring that department to new heights. I have no doubt. So I'm going to let Catherine take over from here. Let's give her a warm welcome, and I'm sure you're going to just love what she has to say. Thanks, Catherine.
I'm short, so I'm going to use this one rather. Thank you so much. It's unusual for me and probably for you too to have an artist in the room. So I'm going to do my best. Vanessa threw down the gauntlet and a challenge to speak about the impact of forensic DNA phenotyping on forensic facial imaging. And it is a very interesting field. I am extremely excited about it, but I've also, through the literature and through my own thoughts, working at the interface of art and science, thinking about some possible pause for thought about what this new technology might mean. Very exciting as a science, but when it impacts the social, how do we think about that translation? So that's what I'm going to try and address today in the time that I have. The image on the screen is part of an artwork I made with a craniofacial pathologist in Hong Kong, actually, so we can talk about that more later if you're interested. Okay, so I was in the UK for my PhD, as Vanessa mentioned, and on my return to South Africa and Stellenbosch University, I established a research space called VizLab. And VizLab essentially works with forensic facial imaging using cutting-edge haptic virtual sculpture technology. You can see there's a device operating on the screen there that enables us to do touch, feel-enabled virtual sculpture to create facial reconstructions of unidentified individuals. So my area of focus is the unidentified deceased. So my interest in the forensic, the phenotyping is really applied in that space. I do recognize that there's a direct application also to identifying persons of interest who might be suspects in a criminal investigation. But within VizLab, we really do try and engage this question, a critical engagement between the science and the social. So how facial reconstruction or forensic facial depiction may have been done prior to the availability of phenotyping data, well, it's craniofacial analysis, knowledge of anatomy, the images in the middle at the top, that's actually an archaeological case, working with very fragmented remains. So it was an interesting challenge. Partial skull broken, a lot of skull reconstruction before the facial reconstruction could happen. And that was an example where ancient DNA was used to confirm the biological sex of that individual, because the analysis done by the forensic biological anthropologist, estimated that individual as being biologically female. But in fact, the ancient DNA showed something else. So in the presentation of that image, that's the 3D shape model that'll come out of the sculpting program. In the presentation of that face, in the model stage, that looks pretty androgynous, right? You couldn't necessarily say one way or another if this is male or female. But how that image is then textured is what brings that information to the fore. And that's something I'll get to in more detail a little bit later. But the other thing that really has impacted the world of forensic facial imaging with phenotyping is the possibility of being a little bit more confident about the color information we might be able to introduce into a facial depiction. We know that you only commission a facial depiction from a forensic artist when the other scientific methods of identification have failed or are not available. So the facial image is always a piece of intelligence. It's not a piece of evidence. And we would default to grayscale so that we don't introduce information that we can't prove otherwise. But for phenotyping alters that prospect a little bit. So what we know about phenotyping is that we are able to now infer externally visible characteristics, or EVCs, such as skin and eye color, natural hair color, some facial features, male baldness pattern, and possibly also height. Forensic DNA phenotyping can also, as I said, offer increased confidence in the presentation of forensic facial depictions of unknown persons, whether they're unidentified deceased people or suspects, persons of interest. And it has a major advantage over comparative DNA identification because it's not comparative. The information is derived from a single sample. And we could see this in a heritage case, so a very high profile heritage case, which was the identification of King Richard III. I don't know if any of you heard about this case or followed this case in the UK. So very famously, or infamously known as the King in the Car Park, because his gravesite was found under a municipal car park in the UK. And this was done by my supervisor and a colleague at the University of Dundee at the time that I was studying there. So I was aware of this sort of top secret project happening in the back room. And Richard III, we don't have photographs, obviously, of Richard III. So the comparison of the anatomical facial reconstruction, that comparison could only be made to other visual evidence, so to speak, and that was paintings. And those paintings carried a lot of bias because he never sat for his portrait, and the paintings carried more ideas about Richard III, who historically has been portrayed as someone who was evil and, not a good guy. And so maybe some of those ideas found their way into the visual presentation. They used forensic phenotyping in the analysis of Richard III's DNA. And so the first depiction was closer to the historical paintings of Richard III. When the DNA information came back, the DNA data came back, the depiction was upgraded. So he was initially portrayed with dark hair and dark eyes, according to the painting. The DNA information suggested something different, blue eyes and blonde hair. But then there was a conversation in the scientific team about, well, maybe many of us, I know certainly I was born with platinum blonde hair. That is not my hair color anymore. Our hair color changes over time. So imagine me as a baby with crazy toilet brush, sticky uppy blonde hair. So the final decision with Richard III in terms of how he now is presented to the world is with a slightly browner, darker blonde hair, but obviously the eye color remains. So it's an interesting evolution and a kind of revisiting of a historical figure with the technology of DNA brought into the facial depiction. So faces from DNA, where we start getting some pause for thought is, for me certainly, is how the authority of DNA is perceived as a gold standard of identification, and then the public perceptions of the images produced using phenotyping data, particularly when this technology has been, I think, relatively quickly commercialized. So some of you may be familiar with a company called Parabon Nanolabs, and on their website you can see these kinds of what they call snapshots, composite profile snapshots. So there on the left, we have an individual, and we're looking, what they're showing you there, what they're inviting you to look at is that from the DNA profile, they can determine or infer facial shape. They can infer skin color, so what is excluded on the spectrum there, and then where he is positioned on the right-hand side of that spectrum. Likewise with eye color, hair color, and freckles. And then interestingly, you've got an inclusion of a map, which suggests where his biogeographic origins might be from the DNA profile. You can see here on the right, there's two other images of the same individual where they're speaking about the potential might be older. So there's an age progression element introduced in the image on the right-hand side. And what gives me pause for thought here is, certainly as a layperson or not as a forensic geneticist, how much of this information should I trust? Should I believe? And if DNA is the gold standard, are these images, which I know are produced by a forensic artist, I know they don't just pop out of a computer looking like this. So there's a human hand involved in this presentation, yet it's set against these kinds of scientific data and percentages that to me, maybe speak a bit to or suggest a little bit more confidence about the truth or the validity of this image than maybe it can hold. And this world, I've just selected some of the kind of key articles that I found particularly useful. And if anyone's interested in this field further, I'd very happily share my reading list with you. But one of the most influential ones was in terms of how DNA can suggest EVCs, facial features, is Klaes et al.'s modeling 3D facial shape from DNA. That's a highly technical article. I wouldn't suggest trying to read it late at night. Manfred Kayser, writing about predicting human appearance from crime scene material, that article received quite a robust response in this letter to the editor by Thurm et al. And I'll be quoting from that in a bit. And then I'm going to end off with a piece of criticism from the world of science and technology studies, which is social scientists, anthropologists, etc., looking at the world of science and introducing a sociocultural perspective on what science is busy doing. And that's from Madam Charek, who's a professor in the Netherlands. And she, for many years, has run a very wonderful research group called Face Race IE. And that's where a lot of the kind of pause for thought in this field really gets some purchase. So in response to Kayser, Thurm et al. Point out that Kayser's arguing that forensic DNA phenotyping technologies, such as determining eye, hair, and skin color, Kayser's suggesting that these should be considered as a biologicalness. That's the term that he uses, with the potential of providing more accurate information than traditional eyewitnesses. They acknowledge, Thurm et al. Acknowledge that FDP technology is both promissory and anticipatory, i.e. we're not quite there yet. But they are concerned that instead of going, striving for individual identification, what these technologies do and how they're then presented visually is that instead of identifying individuals, they create groups of a suspect population. And that there's potentially an idea there that this is another kind of racial profiling. So it's an interesting thing to think about. This is where we might get a little bit philosophical, but they say that this type of genetic policing, to quote them, brings together issues of informational self-determination and bodily integrity of entire groups of people, expectations about how these are managed in practice. And that research and development of biomedical applications in healthcare or disease context and of forensic applications in a criminal justice context have very different aims and are subject to different ethical regimes of law, science, and practice. And that they point out that these ethical issues are not a burden, but are an opportunity for engagement, for technological enhancement, and for negotiating social legitimacy. They also point out that they raise questions not only about their technical reliability, these technologies, but also about the features of the systems in which they are being used. And there's a number of points there that if anyone is thinking about deploying these technologies, it would be really worthwhile having a close read on this to consider. But they do, I see Bruce flip past a slide about the Marianne Vaatstra case, and Charek raises this case specifically in her article, and I wanted to read precisely what she says because she articulates it beautifully. And is anyone familiar with this case in the Netherlands? Yeah. So Charek writes, there is an ironic coincidence between the presentation of the human genome in June 2000 and DNA phenotyping. At the very moment when the human genome was presented to the world as a testament to human commonality and as evidence that race did not exist, in the Netherlands, the high-profile homicide of Marianne Vaatstra spurred new legislation on DNA phenotyping in which race was made into a crucial marker in forensic investigation. In the Vaatstra case, the lack of clues about the identity of the suspect and the availability of good crime scene stains had incited the public prosecutor to ask forensic geneticists for help. The prosecutor was particularly interested in the biogeographical ancestry of the unknown suspect. Because the homicide had taken place in the vicinity of a center for asylum seekers, the local population was quick to suspect the inhabitants of the center, leading to a grim and violent situation. And of course, what happened was that the perpetrator of the Vatnstra murder was a local farmer. And as she points out, sorry, just find my notes here. The biogeographical ancestry of the unknown suspect suggested he was of Northwestern European or Dutch descent. And this is critical. In the media, because a lot of our work is translated in the media for popular consumption. In the media, this probabilistic statement, which we understand as scientists, was translated overnight as suspect is a white Dutch man. And that the same can be said, as she points out to a case in Brockton, Massachusetts in the United States, where a West African ancestry profile might have been translated as suspect is of Cape Verdean descent. So what was interesting to me is, as an artist, is that before all of this came to light within the world of science, I was alive to this artist's work, Heather Dewey-Hagborg. She's done 2 different projects using essentially forensic DNA phenotyping. One was Stranger Visions, where she collected chewing gum, hair, bits and pieces off the sidewalk in New York, used a community DNA lab to produce 3D faces of these unknown people, because she had no idea whose materials she was sampling. I'm not sure if you've got time to play the video, if it'll play now, if it's got sound. No, it's fine. But you can find this online. It's a wonderful little 1-minute clip from CNN. But what her work, as it's evolved, what she is also pointing to, this is a provocation. She's saying, well, how does this technology potentially speak to issues of genetic privacy, genetic surveillance? What if the person you're looking for, or the person whose information you're sampling, maybe are not presenting the same gender to the world as their biological sex, as one example? So her next project, which was about 5 years later, called A Becoming Resemblance, probably Chelsea. Some of you may have heard of Chelsea Manning. Yeah? Okay. So this project was done in collaboration with Chelsea while Chelsea was still imprisoned. So Chelsea smuggled out some DNA samples, I think buccal swabs, I don't know what it was, provided it to Heather, and Heather used her facial modeling software and however else she works, to produce these 30 facial sculptures that could all be versions of Chelsea Manning based on her DNA profile. So the installation is called Probably Chelsea, and it speaks to this question of, well, how sure are we really? And what does this profiling suggest? And that we all really exist on a spectrum. From our experience, and I'm looking at Dr. Laura Heathfield over there, we're busy with a project at the moment where we are using this technology in a research project involving 5 complex unidentified forensic cases. And I have been thinking about this for a while as someone who receives biological profiles drawn up by forensic anthropologists, where they are looking at the osteology and making inferences about the person's biological sex, their age, and their ancestry. And I use ancestry under caution because it is a controversial estimate to make. And the one thing I'm starting to think now is that maybe of those 3 things, determining biological sex, age, and ancestry, age was always the most kind of broad. You know, you would express age in quite a wide range. And for me as an artist, when I received that report saying this is an unknown male, you know, between 45 and 65, I'm like, well, that's helpful, because that could look quite different, someone who's 45 to someone who's 65. But what we're starting to see is that maybe even the concepts of ancestry and sex, gender, are not as stable as we once thought. And this for me is very interesting, and yet another moment where we can put our critical heads on. Sorry, I forgot to play that. That's just again, it's just a view around the installation of the Probably Chelseas. So all of those 30 different faces from the same sample. So this is a group that I volunteer with in the US called the Transdode Task Force. I won't talk about this in too much detail, but suffice it to say they look at instances where historically gender non-conforming people may have fallen through the cracks of an investigative system. And if they've either gone missing and their families have reported them missing as male, but they're presenting in the world as female, or if they're unidentified individuals who, you know, we fill in forms for missing and unidentified persons, you don't get more than 2 blocks to tick. You either tick male or female. That may not be everyone's reality right now. So this was a little experiment we did where there is an unidentified individual associated with an unresolved serial killing case in the United States, the Long Island serial killer. And this individual called Mia Santiago, who hasn't been reported missing as Mia Santiago. Her family reported her missing as Terrell Santiago. So people are out there looking for a missing male, but Mia was not presenting to the world as male. One of the unidentified bodies, skeletal remains found in the dunes in Long Island, was clearly someone female presenting, but the biological anthropology report said that this individual was male, an Asian male. But what Asian looks like is a very wide possible area of interpretation. So we did a little bit of an experiment, me and Anthony Redgrave from the task force, where we did a face pose correction using a piece of software to adjust the face to be front facing, which is the standard view for a forensic depiction. We took the existing facial reconstruction of the so-called Asian male, why one would produce a male presenting image only when this person was probably walking around the world also female presenting. Why not do both or do an androgynous one? I don't know the answer to that. But I was interested to see whether at least the anatomy of these two faces would match. And if there was some correspondence, it would be enough, I would say, to say maybe reinvestigate this and at least do a DNA test to possibly exclude this individual. So just to keep it open. And you'll see that the match is quite uncanny. Those two faces, in terms of where the interior facial triangle and where the features match, regardless of visual presentation, is enough for me to say, this could possibly be the same person. So let's do a DNA test to exclude. I'm not sure where that's gone. We did this with a view to introducing it to the agency concerned to say, please at least consider this as an option. Where AI is coming in, and then I will end off. AI is offering us some interesting affordances and challenges, I think, much like the forensic phenotyping, where there's much excitement and also much pause for thought. So these are two forensic depictions of another transgender person, a murdered individual, known as Julie Doe, so unresolved, and just two different depictions from two different artists, which I include here to demonstrate, I suppose, something about visual sensitivity. But the internet has had great fun with these images, with things like FaceApp, which we can all use as part of social media, and have shown different versions of gender presentation using very, very quick, cheap, free technology that's essentially in our pocket. Something we're experimenting with in VizLab now is Artbreeder. So I want a faster way of adding texture to my 3D facial model, so I don't have to do that painstakingly like digital collage. But what we're finding now is that these engines are altering the source image that you input too much to be acceptable. So this is an experiment done by Daniel Fosshart with some facial reconstructions produced for the RCMP, using Artbreeder to add texture, but we can see those facial features are changing too dramatically. They're no longer true to the original anatomy. So again, exciting, but pause for thought. And this was an interesting example that sped past me on Twitter recently. So the idea of a super correction to a low resolution image, which is something as a forensic artist, I have to deal with low resolution images quite a lot. But if that's your original and that's what the result of the AI image correction is, it's Houston, we have a problem. So I won't go into too much more detail here. I can see my time is nearly up, but just to say that I'm conscious as a forensic artist that we don't have a seat at the table of the organization of scientific area committees. And although we touch almost all of the blue subcommittees over there, facial identification is in the purple section, we can now see how this is reading across to the biology and DNA area as well. And not having a seat at the table is somewhat disappointing sometimes, but it also is an opportunity because we're not necessarily bound by some of these rules. But I just want to end with one slide, which is really the kind of takeaway for the session today. So going back to this idea of the potential racial profiling of forensic DNA phenotyping, just to end off with these words from Madam Chirek again, where she says, the work of the face is the production of appearance, and it may turn into phenotypic othering, the racialization of specific groups of people based on a heightened visibility in specific. We do need some social happen way used by thank you for taking a minute extra.
Oh, thank you. That was amazing. I'm sorry that we've only got such a short time for all of these presentations, because you have to admit they are fascinating. That really is. I think you really are pioneering and breaking frontiers, and we look forward to you being on that panel, bringing a completely different view. So thanks so much, Catherine. So our next speaker, Mr. Yasin Farah, is from Somalia, and I always say, if ever there was a real-life depiction of a CSI officer from, the crime scene investigation series, I actually think it would be Yasin. He just needs to put on the Ray-Bans and the leather jacket, and you have to work on that blue steel look, Yasin. You're guilty. But he's the real deal, and he's recently been appointed as the National Forensic Expert by the Attorney General of the Federal Government of Somalia. They have a project called the SOMJUST project, which Yasin's going to tell us about, which is a partnership between the United Nations, Somalia, and the international community. And it really showcases how mutually beneficial partnerships really advance forensic platforms in Africa. We're really excited to have you here today. Yasin has, through the Somalia government, brought himself here to present, and we thank you for sharing your knowledge and expertise. He brings 15 years of experience as a forensic scientist to the table today, and has obviously a unique view in terms of the African context, which is so important when we speak of the need to have experts who live and work and have the same resource to really have big practices and to be able to share it with us. So I'm going to hand over to you, Yasin. Thank you so much for coming, and we look forward to your presentation.
Thank you very much. Thank you for such a wonderful introduction, Vanessa. Thank you. Good morning, all. I'm delighted to be here. I'm delighted to be taking part in this amazing forensic symposium. This is my second time attending the DNA for Africa's forensic symposium, and this event gets better and better every year. So kudos to organizers for putting together once again a wonderful, amazing forensic symposium. So well done. Thank you. So today, I'm here to share with you the steps Somalia's federal government are taking to strengthen. I'm here to share with you the steps Somalia's federal government are taking to strengthen its criminal justice system by aiming to enhance the country's knowledge and skills in forensic science, and by also aiming to build a capacity in forensic science services. I will also attempt to share with you the comprehensive approach to forensic capacity building that we are currently taking, The aim is to cover the entire forensic process from crime scene to courtroom. In short, the objective of this presentation is, first of all, to highlight the Somali Justice Program, the SOMJUST, which is designed to advance forensic investigations and the use of forensic science in Somalia, the use of forensic evidence in Somalia. Secondly, this presentation will outline the strategy and the methods we are employing to boost forensic investigations across Somalia. The third point will address the why and the need to harmonize forensic investigations and forensic activities in Somalia and the development of a national forensic plan. In addition, I will also touch on the challenges that we occasionally see and that makes difficult to efficiently conduct forensic work in Somalia. Often when you Google and write Mogadishu in internet search engines using the English spelling of my nation's capital, the English spelling of my nation's capital name, often you will see these images. A ruined and abandoned city where buildings are pockmarked with holes from bullets and grenades, pictures of car bombs and terrorist attacks. And whilst some of this is indeed true because of the ongoing armed conflict between the terrorist group Al-Shabaab and the government's armed forces in the country's long-run civil war, it's not the whole truth. These images often are from the 1990 civil war of Mogadishu. When you write Mogadishu, the spelling in the of the capital's name is Somali, a different narrative and pictures are on display. A more cheerful and optimistic picture emerges, where we see a city in a full recovery mode, where huge investments in housing developments are taking place, among other developments. A city that's heading into a brighter and more peaceful future. Likewise, after 2 decades neglect of our criminal justice system, we are also now rebuilding, developing our criminal justice system again, and we wish to put it on the right course with the help of forensic science in order to have effective, credible, and fair criminal justice in place again. Therefore, the Office of Attorney General has recently initiated a 2-year program called the Somali Justice Program, the SOMJUST, with the support of 2 international partners in security and the law and the rule of law arena, namely the International Development Law Organization, IDLO, and the Bureau of Narcotics, the Bureau of International Narcotics and Law Enforcement Affairs of the United States Department, INL. INL helps with the funds, and IDLO helps with expertise and implementation. One of the main components of the SOMJUST program is capacity building initiative focused on forensic evidence collection and forensic investigations across Somalia. The SOMJUST program also responds to the national development priorities as outlined in 2020-2024 National Plan, and it aims to contribute to enabling criminal justice institutions to deliver efficient, equitable, accessible, and accountable justice service to Somali citizens. Forensic evidence provided by forensic laboratories enhances the capacity of Somalia's rule of law by aiding the delivery of justice to victims of crime, particularly in sexual assault crimes. Somalia is a federal republic with 5 federal member states and 1 federally administered region, which is the capital Mogadishu and the surrounding area. There's also Somaliland, the northern region, which is currently outside the federal system. And because of this federal setup, each member state has its own independent police force with a differing capacity in conducting forensic criminal investigations. Puntland is the oldest federal member state, which was established 25 years ago, whilst Hirshabelle, lower down, is the youngest and the newest federal member state, and was established as late as in 2016. There is also only 2 forensic laboratories in the country. The Bureau of Forensic Science, which specializes forensic DNA analysis, with a fully equipped DNA laboratory, This bureau was the first of its kind forensic bureau in Somalia and was established only 6 years ago. However, this forensic bureau in its short history has achieved landmarks in Somalia's history. The bureau has successfully conducted and generated the first DNA profiles done inside Somalia. Secondly, this bureau has made possible and allowed also for the first time in Somalia, the courts in Puntland state of Somalia to make judgments based on DNA evidence and deliver justice by convicting criminals who have committed heinous crimes such as rape and murder. A bit biased, I was a senior forensic scientist at this bureau for 5 years. So. The other forensic laboratory is the Forensic Science Laboratory in Mogadishu, which is under the Federal Police Force of Somalia. The ballistics lab is the main section of this lab. The FSL also has a latent fingerprint lab and a digital forensics laboratory, among others. ECTAB of the United States Department of Justice provides technical and mentoring support to this lab. I think Mark Mogul is here. I was standing yesterday. So we thank ECTAB for the support to this lab. SOMJUST, the goal is to harmonize with SOMJUST, to harmonize the approach towards in which in all federal member states, the way they conduct their forensic investigations, crime scene investigations, collection, documentation, and packaging of evidence prior to submitting evidence to these two laboratories. So what's our strategy? Forensic investigations and boosting forensic analysis. Well, our method and tactic on improving forensic investigations is to take a holistic approach that covers the entire forensic chain of process. This including strengthening of the forensic know-how of our law enforcement offices, enhancing our forensic services capability, and also improving our evidence collection facilities across the country. As the old saying goes, forensic science starts at the crime scene and ends at the court. And with SOMJUST, we intend to provide a targeted forensic education to CID officers, criminal investigation officers, prosecutors, and judges. We started with this project by bringing in the scientists. A national forensics expert was appointed, who is tasked to coordinate forensic science activities in the country, yours truly. In addition, also, we just brought in an international forensic expert to provide technical and advisory support for the implementation of this program, the SOMJUST. Secondly, we recently established a national forensic forum, which is jointly chaired by the Federal Attorney General, the Federal Chief Justice, and the Federal Police Commissioner. And this forum is intended to be a platform that brings together key actors and decision makers within the Somali forensic science services, including international agencies in the field that operate in the country, with the objective being to promote collaboration and coordination on matters relating to the development of forensic capability and services in Somalia. The initial phase of SOMJUST is a research-based mapping exercise to identify and assess the current forensic service activities, the needs and the gaps in the country. Furthermore, the mapping exercise is also expected to identify legal and logistical gaps which are preventing effective forensic process in the country. The outcome of this exercise will be the basis for the recommendations on the way forward. Also, the expected outcome of this mapping exercise will be the basis of the development of National Forensic Plan, which is expected to harmonize and guide the Somali approach to gathering, preserving, and analyzing forensic evidence. Another key SOMJUST activity is the establishment of secure storage facilities for forensic evidence at criminal investigative department offices at key regional CID offices. The main CID units in federal member states will have a designated and fit-for-purpose evidence storage facilities, which are supported by robust procedures for management of evidence. Equally, we also intended to put in place logistical arrangements for the transfer of evidence from crime scene to the laboratories, as well as providing tools and kits for proper and reliable evidence collection and preservation of evidence. A challenge that we face is the country's forensic work is often hampered and handicapped by difficult logistical chain for evidence transportation to the laboratories because of the ongoing armed conflict in some parts of the country, in combination with the limited availability of reliable transportation means. Very often the most reliable route between federal member states and Mogadishu is air transportation. This is a very costly way to operate to submit crime scene evidence to the laboratories for analysis, particularly for our various police forces with a limited budget and resources. With SOMJUST, therefore, we aim to organize and improve logistics of the transfer of evidence between federal member states and the 2 forensic laboratories in the country. Further, the SOMJUST program also includes a capacity building segment for criminal investigating officers with the intention to enhance their forensic knowledge and skills, thereof improve forensic evidence recovery and handling by ensuring the scientifically based methods are employed for the collection, preservation of crime scene evidence. This is to protect the integrity of and evidentiary value of evidence, as well as maintaining the chain of custody from recovery to the courtroom, and ultimately ensure that the evidence, when presented in court, it will withstand the scrutiny to its integrity, transparency, and traceability. Another key SOMJUST component is providing technical support to strengthen forensic medical examinations at government-run hospitals. Medical professionals in these hospitals often present very limited forensic know-how in the collection and handling of biological evidence. This capacity gap has led to suspension of several criminal cases by the existing forensic laboratories, particularly the forensic DNA laboratory in Puntland, because they failed to produce credible forensic results due to substandard sample collection. Therefore, it's imperative that medical facilities in the country that are responsible for initiating the collection of biological samples from possible victims of sexual crime have well-trained personnel in forensic evidence collection and handling. Those of us who have dealt with or been part of forensic investigations of sexual assault crimes are aware of the collection of biological specimens being crucial in obtaining the scientific proof that could support an alleged victim's rape case. SGBV, or gender-based violence, are also an area that SOMJUST also paying attention to. Because, and sadly, women and girls continue to bear the heavy burden of ongoing conflict, lack of stability and security in Somalia. A recent human rights report from 2020 reported an increase in the incidences of sexual assault violence and also often victims being killed. And also, and sadly again in Somalia, crimes related to SGBV, particularly rape cases, largely remain unprosecuted because often there is no scientific proof that allows linking the criminals to the horrific crimes they've committed. Therefore, it's critical that forensic sexual examinations and the forensic evidence collection are carried out properly, and so reliable scientific evidence is generated in order to assist the delivery of justice to victims of sexual assault crimes. For this reason, SOMJUST also include a targeted forensic capacity building for frontline medical professionals at government-run hospitals. We also will provide appropriate evidence collection kits for this type of crimes. The last component of SOMJUST forensic capacity building is to raise the forensic knowledge and the use of forensic evidence among judges, prosecutors, and lawyers. The aim here is to inform and familiarize judges and prosecutors with the importance of evidence guided through scientifically sound methods and procedures. You see, the use of forensic evidence, particularly DNA testing, is recent to Somalia. We've just started 6 years ago. Consequently, prosecutors and judges often present limited forensic knowledge in weighing forensic evidence and determining its evidentiary value. Therefore, it is critical that judicial actors in Somalia also understand forensic evidence, its advantages, pitfalls, in order to evaluate appropriately any such scientific evidence put forward in judicial case. in particular is the judge's role to be gatekeepers. They're meant to be vetting and evaluating correctly scientific evidence submitted to court. Hence, it's necessary that they are sufficiently skilled for this task and are able to skillfully apply admissibility standards for forensic evidence, and also are aware of pitfalls of expert scientific opinions. Therefore, the sum just includes as well the development of a primer or small booklet or guidance for prosecutors, judges. Moreover, we will be conducting workshops as well to educate judicial actors in forensic science investigation and interpretation of forensic test results. This photo shows the Kenya National Forensic Laboratory. It's brand new campus, which was just opened last year. And with SOMJUST program, we also intend to pave the way to ultimately realize and establish our own National Forensic Institute and join our East African colleagues in Rwanda, Kenya, and Uganda in having a dedicated forensic institute that will lead and coordinate Somali forensic service activities. In summary, our SOMJUST forensic capacity building, we aim to improve coordination of forensic activities and services through the establishment of National Forensic Forum. We also intend to provide a targeted forensic capacity building to our CID officers, prosecutors, judges, and certain medical professionals at government hospitals. We aim as well to enhance evidence integrity by establishing secure forensic storage facilities across the country for the preservation of evidence. We will also improve evidence transportation to forensic laboratories. Evidence needs to be submitted to the laboratories, which is currently not being done at a good rate. In addition, we intend to develop a national forensic plan that will harmonize the approach towards gathering, preserving, and analyzing forensic evidence in Somalia. And ultimately, our end goal is to achieve and realize a fair criminal justice system in Somalia through forensic science. Thank you for listening.
Thank you so much. Thanks, Yossi. Thank you so much. It always is so interesting to see how different countries approach the development of their own forensic platforms, and I think it's definitely something that we're going to watch. And I know that you've recently appointed an international forensic expert to assist too. And I was just thinking when you were in maybe last year, maybe next year we come to Somalia. Maybe we should think about that, because it certainly looks like the most people know who you are. It's Associate Professor Keyfield, Cup again, and Lieutenant Colonel Charlene Otto. And we're going to be discussing this panel is going to be decoding the challenges of complex DNA analysis and highly degraded samples. So I'm going to pose a few questions to these panelists, who you will read from the bio, and I don't know if you can scan the full bios and of all the different panelists on your name tag or on the website. And I'll ask them a few questions which we've prepared, and then I'd really like to get questions from the audience. This is our opportunity to engage, so that for the next 2 days you don't always have to sit and listen. There are a lot of experts in the room who can share their expertise. Just ask that if you do ask a question, that you just ask a question and don't use it as an opportunity to make a statement, because it does interfere with the panelists. We'll have lots of opportunities to talk at tea time, but it really is just to pose a question to the panelists or challenge them on some of their answers, which I'm sure they'll also enjoy. I've also got the online audience, just so that you don't feel like you're being excluded. I can see your questions, and let me just check that this works. So proof that please engage with us too and send us your questions so that we can ask about those too. So I'm going to just, do you mind, all of you, just quickly introducing yourself, passing the microphone and just introducing each of yourselves briefly to the audience. Thank you. Maybe start with Asha and where you're from. That would be great. Thank you so much.
Do you hear me? Good morning, everybody. So I'm Asha Oklu, Senior Forensic Scientist from Mauritius. So I've been in the forensic field for 17 years, and I'm glad to be here with you and looking forward for this panel and also for the whole conference. And it is indeed a great opportunity for me to be here. Thank you for the organizers.
Hi, everyone. My name is Laura Heathfield. I'm an associate professor at the University of Cape Town. I head up the biomedical forensic science programs. I do a lot of research in post-mortem DNA, and I also consult the forensic pathology services on DNA-related matters.
Hello, everyone. My name is Yasin Farah. I'm from Somalia. I'm currently serving under the Attorney General's Office of the Federal Republic of Somalia as a forensic science advisor. I have a background in forensic chemistry. I work in laboratory for over 15 years, both in UK and Sweden, later on in Somalia. So, yes.
I'm Bruce Podoli. I'm from the USA, but my heart is in Africa.
Yes.
So I think that's it. I think you've heard enough about me already.
Morning, everybody. I'm Charlene Otto. I had been at the Forensic Science Laboratory now for 30 years. This morning, somebody addressed me as Tanny, which is auntie in English. And yeah, I must admit, I am there now. So yeah, thank you. Thanks for being here.
Thanks. So, Tanny, if we can start with you. Actually, so not, because I always talk about Charlene in many of the cases that she's, I think over 600 cases that you testified in South Africa. Definitely one of our most experienced reporting officers, always comes out in her Chanel suits. So, and you have not disappointed. You are not, absolutely not. I'm going to start with you though. Can you just, I think just to set things going, just briefly explain what are complex DNA samples?
I think Bruce had actually also had something on that in one of his slides. Complex samples or complex cases could be two different things. Mostly it's those extremely degraded samples, like tissue samples. In our case, it's mostly tissue samples, bone, where you might actually struggle to get a proper DNA profile. But complex cases can also be cases where there are multiple perpetrators, multiple victims, multiple samples that you have to deal with. So the whole coordination of that case becomes hugely complicated. And also important, to remember, we have to keep objective. We have to stay objective in a whole approach in these cases. Yeah, so I think it's actually two-legged. Usually degraded samples, and then those cases where we have multiple perpetrators and orphans, or both.
Okay, thank you. I think that the next question I'll ask Laura, why are complex DNA samples so challenging? Because I know in your laboratory you deal with a lot of challenging samples. Maybe you can just give your viewpoint on that.
That's quite a wide question. So complex to extract usable DNA. And I think at the start of the process of sample preparation, there can be a lot of optimization in that area. And then downstream, the quantification can be tricky because sometimes, depending on your quantification method, the large fragment might not amplify if it's a weighted sample. And then decision-making around downstream process might be limited. There is some way to optimize the DNA profiling processes or using alternative markers like Bruce was discussing earlier, or using massively parallel sequencing. But I think the whole complexity is surrounding the resources as well as the time that these processes take. It's very time consuming. But also think that the better research we have into these issues will support the development and us extracting usable DNA from the challenging sample types.
Do any of the other panelists want to add to that in terms of their own experiences in their laboratories? Perhaps Mauritius, Somalia, Bruce. I mean, yeah, I'm sure you also have a perspective on that.
Thank you, Vanessa. I'll just continue on what Laura said. For degraded sample, indeed, it is very challenging. And we know that in Africa, if we have countries who don't have yet well-established labs, forensic lab, we can't even think about SNPs or next generation sequencing. So we have to do with what we have in our lab, and optimization of the different protocols are very important. In Mauritius, we'll be having challenges with bone sample, human remains, where it was difficult to obtain even a partial profile to be able to do an identification with these human remains. So what we did is we set up a small team, which we did an internal validation and optimizing the extraction processes, because you might get commercial kits, but very often these don't help in all circumstances. So what we did based on the theory that we learned and then the use of the commercial kit, we devised our own method where we optimized the calcification process, because to obtain profile from bone sample, the challenge is really how to get to the DNA and get rid of all the calcified products. So we optimized the decalcification process, which is quite lengthy, but at the end of the day, it was successful for us to get full profiles. So just to say that forensic field is indeed challenging. We might be having complex issues, but the real way is to play around with the science and how to apply this technology to help us in the forensic field. Thank you.
Thank you.
Vanessa, can I add?
Yes.
I was just thinking as Asha was talking that I'd like to encourage labs to share findings when things don't go well. What are your negative findings in this area? I think so often when we look at publications, we only see what worked, and that might be very specific to that environment. And our environments here are different. There's different seas, there's different fires, there's different vegetation. So the environments that the human remains are found in is different. And so if we can share within our communities about what procedures didn't work, I think it would save labs trying things that we already know don't work.
Excellent point.
Yeah, and just what I add as well, to agree with Asha, and it's very, when it comes to resources, to buying these technology that's needed to do properly mixed analysis, we cannot be affording it in Somalia or maybe in other parts in Africa. But what we've noticed also is often we get partial profiles because poor sample collection at hospitals, etc. So we are investing in buying proper good swabs. I think Professor Budol mentioned earlier, and training them. So that is one way we are trying to address that. Other cases also technology is needed, because we often see in Somalia gang rape that's becoming particularly, offenders being in their late teenagers, where some of them are shared kinships. So technology will be needed, and we are needed. So that needs to be invested as well.
Vanessa, if I might just add something to what Asha had said. We also in South Africa deal with a lot of burnt bodies and even decomposed bodies to a certain extent. Now, should it be in a criminal matter, what I have found to work is to build a relationship with the forensic pathologists. We meet them at court, try to get them to, and then what happens while they are actually busy with the post-mortem, they can call you and tell you what they see. Because sometimes a burnt body is extremely burnt on the outside, but closer to the bladder area, there might still be some pinkish flesh. and pink is good. It's viable, it's DNA. And then also to play around, because this is what happened at our lab. They played around with different types of bone samples. We always focused on the femur head. Now slowly the focus is going over into more the ribs, which is like, it's completely different, but we get good results from that. And also the long bone, if you can maybe teach your pathologist as they are doing the post-mortem to actually cut the long bone, and because the bone marrow inside is usually still viable,
Okay.
to swap bone marrow, and it gives brilliant results.
Thank you. I think Laura, you touched on a point about the communication, and maybe this question can go to Bruce, seeing as though you've published probably the most, well, we know in this room. So how do you communicate the challenges, successes, and limitations to the investigative and judicial professionals? So we've spoken about the need, but have you got any recommendations as how best to do that?
Crayons and drawing pictures, no. Of course, this is the hardest part. As I said, let's take this situation of going to court. You have this impression, and it may unsettle some of you, this impression that you're going to educate a judge or a jury in 30 minutes on how to do DNA typing when it took us years to get where we are. So what you're really doing is trying to convince them that you have the qualifications and experience and the credibility that they should trust you with your interpretation, not that they understand it deeply. But there are some ways to talk to people without being the problem being scientists. Scientists try to get very up about themselves, and we use big scientific terms because that makes us look smarter to everybody else, but it can be very confusing. So I try to train people, and testimony is, you have to explain DNA typing to me. You have 30 seconds, 1 minute, and you can't use Hardy-Weinberg equilibrium or nucleotide or allele, because if you can do that, there are ways you can bring this to a level that helps them. So, but you're not talking down to them, you're talking equally with them. And I would challenge any of you here to do that. Can you do that in 1 minute, explain it, and get to that next step? That will help a lot. The other part is to put yourself in the shoes of someone else, as opposed to always being the center of attention with the work that you do. When you talk to investigators, they have needs, they have goals. Their mission may be different than your mission, but understanding it can help with gaps as well. And so it's all about trying to understand those you serve, you interact with, and also in a way that people can digest what is going on without sounding scientifically arrogant, I would think is a good way to put it.
Thank you. I mean, this can really go to any of the panelists, and maybe you can each give a perspective on it. How do complex DNA analysis and highly graded samples impact the interpretation and reliability of forensic DNA evidence? And what strategies can be employed to mitigate potential limitations? I don't know if anyone wants to start that.
You're going to want me to do that one?
Yeah.
Yeah, I can start. And when it comes to complex DNA cases, particularly gang rape, especially our Bureau of Forensic Science in Puntland is so we can see just one way to go.
the gist of it. If you know the case history, if you can get family around, personal belongings and everything, so this helps a lot in the case. And at each step, we know implementation of the quality procedures of the lab. It's not about deviating, but fine-tuning procedures just to make sure that we are able to get something out of the samples that have been brought to the lab. Because as Professor Bruce mentioned yesterday, it's not about bias, but we have the responsibility to serve criminal justice system. It is our need to optimize the protocol to make sure that we are within the limits and at the end of the day get results solve the particular case. So it happened that some cases we are not able to solve them because the samples are highly degraded. But then we move to the other exhibits that are present that we receive from the case, might be clothing items, because nowadays talking about touch DNA epithelial cells, it's not only about recovering from the challenge sample, but trying to explore other opportunities where we can recover DNA for that particular case.
Excellent point, Asha, absolutely.
And Vanessa, also from my side, to add on to what Asha had said and to what happens in Somalia, especially with the gang rapes, because remember, especially in the Western Cape, we've got the same problem with the gangs.
Yeah.
And usually part of the initiation is raping. Now, the ideal is obviously to be able to link everybody to the victim or maybe two victims, but it's not always possible. You always, once again, comes in the bias, because this is what we want to do. And according to our interpretational guidelines as well, we can't just exclude anybody. You have to be sure by analyzing every single sample that that guy is now actually excluded. And if you do not
but a short fix where from the side come in the expertise in education programs, experts to get information. Sometimes else trying to fix it when it's already been done. By getting that information to you, you becoming the trainers and the experts, you'll identify what the challenges are and be able to express the limitations better. So it's really more about investing here and getting that expertise so the next generation has got it from the people within Africa.
And if I can add to that, the expertise might also not be solely within the forensic science field. I come from a human genetics background, in a more clinical setting, and there are a lot of tools that we could borrow because they face similar challenges. So for example, in cancer research, the sampling of a tumor for specific cells within a tumor is like a mixture sample. And the technologies and tools that have been developed to sample specific cells doesn't need to be reinvented, but it's not within our field. Another example is the use of formalin-fixed paraffin-embedded tissue, which is often obtained at autopsies and is a tissue sample that I've worked quite a lot with. And by far is the most degraded sample, far beyond bone and teeth, that in my experience. And there are lots of strategies and protocols that exist in the clinical setting, which we could also apply to these challenges.
Thanks. I've got a few questions from the online chat, which I'll get you. Is there anyone in the audience who would like to ask a question specifically to some of the issues we've raised? Do you mind just, maybe we need some help with the mic. Yeah, share it. Thanks. I'm multitasking.
Good morning, and thank you for the informative panel discussion this morning. I just want to find out, and as much as I allude to the fact that there's a difference between complex samples and complex cases, I've noticed a lot of times when we work with complex cases, and as we conclude, we say to ourselves, I wish the crime scene examiner did this and did that. So I'm asking, what would be your opinion with regard to analyst guidance crime scene investigation? A lot of times I feel if a case is identified as complex from the onset, is it difficult that the analyst can be involved in exam, and would that add value in terms of getting better samples and better results at the end? Thank you.
I think you hit on a very good point. Your question already sort of answers it in itself, is if you work in a siloed fashion where, you know, the analysts are doing their work and the crime scene are doing their work and the lawyers are doing their work, and you're not cross-talking, you're not going to get the feedback. And I usually make a joke about, I want to swab this table here. So I'm, as a crime scene investigator, I invented this 20-centimeter diameter swab because I could cover the surface in one swab, and I really collected all the evidence. And then I sent it to the lab who has tubes about this big, and the swab doesn't fit into the tube. It's a disconnect, the same way I've got all these great things coming in, but I can't handle it. And although it's just a joke, in a sense, it's a reality that we may be getting samples from the crime scene, but they're not yielding anything. Or some types of samples are. You could have a case like a violent murder, and there's a pool of blood, and you're looking for the blood of the perpetrator. So you go to the pool of blood and you collect it and send it in because you can see it, but that's actually of no value because that's the victim and doesn't really help point to something. You would say, stop sending me those samples. Send me a sample that might be a small particle drop away from the scene or something like that. And it's just these little things that occur that doesn't happen. Within the lab, we have those problems. If you know, in my lab, we actually had the person run the whole process through so that they could have feedback from different parts of it. And we had some labs that we had to investigate because of errors and contamination. One part didn't know what the other was doing, and contamination was created in one, but the results were being interpreted reliably on the end and going out there into the real world. So these kind of communications are critical, and feedback, and I would recommend laboratories once a quarter, once every 6 months, get together with their groups and exchange their experiences, just like we mentioned, for problems that occur, what within the system that's not being done very effectively.
In South Africa, we have a system of forensic field workers where the crime scene management, also policemen, part of a local criminal record center, where they are actually trained by forensic analysts, by crime experts. Now, that doesn't guarantee that you're not going to get bad samples, but at least they have some understanding of how to approach the crime scene and what could be important and what to look at. And I must admit, since that system had started coming into play, it was about 2011, we have seen a huge improvement in the collection of touch DNA samples. Initially, we had hardly any success with those, but yeah, so we could see an improvement. It's different if it's a extremely violent scene, crime scene, where there's maybe a need for a blood stain spatter analyst to reconstruct. Those people are also trained extremely well. They might not be forensic scientists in the same way we are with the same science, but they look at things from a different angle, which is extremely important if you want to have a whole combined effort in the end of the day for a successful case. So yeah, training out there, because as analysts can't always go to the crime scenes themselves. So those people must be trained well.
Thanks. Actually, there's a question online that touches on something that you've just spoken about, and that's the amount of the swabbing. And I've heard this, I think, Joe, I don't know where you are, you've mentioned this before. Can one collect too much DNA, epithelial cells, when swabbing, and will this have a negative impact on the results? I don't know if somebody can, not, the opposite of highly degraded, but I think it's a very relevant question, and it's the right panel to ask this.
I'll respond on the previous question first, Vanessa, because I would like to share the practice that we do in Mauritius, especially we're a small island. Our lab is not that big, but I can say it's performing well. And as forensic scientists, we are called upon crime scene examination. So in major cases, rape cases, homicide cases, and murder cases, so we start from scratch. It would mean that I'll be going on the crime scene, working together with the scene of crime officers, try to optimize on crime scene examination, because very often what police officers or crime scene officers, how do they look at the crime scene? We see the crime scene from a different perspective. Each one has their roles to play. So there is a proper teamwork crime scene itself to ensure that proper exhibits are being collected from the crime scene and being brought to the lab. So this is to answer your question, sir. And for your previous question, Vanessa, I would say that the process is we can collect too much or too little, but we need to quantify that DNA before going for further processing. Too much DNA is not good because we might not be obtaining a proper profile. Too little DNA also is not good. So the process is that we collect DNA, we collect samples, we do the extraction, that is the isolation, we remove the DNA because this is what we are going to use. But to know how to use it, what amount to use it, we need to quantify that DNA. And it is only after quantification that it goes down further the lane.
Great, thank you. Any other questions from the audience? I see, do you mind? Oh, you're ahead of it. Would you mind just, as you ask the question, just introducing, just saying who you are and where you're from? It just...
Thank you, Vanessa. I'm Joe Smith from the SAPS Forensic Services. My question is related to the quality management system. We heard a lot of the panelists talking about optimizing, fine-tuning. You've developed standard operating procedures, which is based on your validated techniques. How is this processed and this evidence where you have optimized and deviated from your standard operating procedure presented in court? And how do you deal with the questions from the defense? Thank you.
Me? Okay, thanks. Wow, that's a lot of questions there. Okay, well, in a quality management system, obviously, if you set you have three things. You have policies, protocols, and proof. So I always call it the 3 Ps. And so documentation is your proof, and policies are what service you provide, and the protocols you use. There will be situations where your protocol doesn't address the scenario. So in a quality management system, you are allowed to have deviations if you document it in purpose, not to be a routine thing, but for the specific case. As far as the defense trying to attack you, it depends on the strategy. That's their job, to try to diminish the value of the evidence. You have to demonstrate that what you've done through the proof, that this is a proper process and it's based on principles that are supportable. So it all is coming upon you to do good quality work. But I can say is, if you always follow your protocol and you don't think about it, there will be cases where you will be wrong. So you have to think about it using your protocol to start with and assess and say, does this make sense? If it doesn't make sense, then we have to think of alternate ways to do that, or errors will occur. And I used an example yesterday, if you remember, is the lab called a certain number of contributors in a mixture inconclusive because it's too complex to analyze manually. However, by looking at the evidence, the person who was considered the suspect to contribute to the evidence could not be a contributor because his alleles were not there at the informative loci. But the policy was inconclusive, but this was a failure in getting a proper interpretation. They should have excluded the individual. That's a deviation from what the protocol says, but it's an appropriate thing. Now, in that particular case, I don't think the defense will be arguing with you, saying, I want to disagree with you because you excluded my client. But the idea is there can be alternate situations where it could be inculpatory data or leads that could have value, but because we set a policy, we're not thinking. So, but it comes down to documentation, proof, and support.
Thank you. There was a question here, and Bonnie's also got a question. And then afterwards, Bob. Yes. Hi, Bonnie. Welcome.
I'm Bonnie Karigamu from the National Prosecuting Authority of South Africa. Some of you I know. My question is the following. A few years ago, I did a talk to the forensic pathologists, and I titled it "The Forensic Pathologist as the Star Witness," because often we don't have eyewitnesses in our cases. It's quite often that we don't have eyewitnesses, and we rely on the forensic pathologist. So my question to the panel is, how ready are your analysts to be that star witness? I think, Professor Padoli, you spoke about communication, of being able to communicate your knowledge to the court. And sometimes we struggle with some of our colleagues not being able to relay that message properly. And often that evidence is absolutely crucial in a case. So I would like to know from the analysts, from your environment, what training, if any, are you giving to prepare your guys to go and effectively testify in a court of law? And if there isn't specific training, aren't we beyond the point now already? We should have been doing it before, and are there plans to do so in the future? Thank you.
Just before you answer, we've got an entire panel on this afternoon, Bonnie, on the effective communication of forensic science. So just bearing that in mind, we will talk really, and actually maybe you can come and join that panel. It'll be really useful for you to have you from your perspective as well as theirs. So just bear in mind that this will be a whole discussion as well when maybe one of you answer that question.
Okay, then Advocate Bonnie, I'm not going to give a long answer, but from our lab, from South African Forensic Science Lab, we have a whole program in training reporting officers to go to court. From what Professor Bruce had said, you have to be able to explain a difficult DNA process in one sentence, a minute, as short as possible. Yeah, and I also do teach them that the DNA analyst is never the star witness. So there's a difference between being able to be a good witness and to be able to relay your knowledge in layman's terms and to be able to convince the court your result is a reliable and a trustworthy one, but not being a star witness.
Thank you. I'm going to take one question from the audience, and I promise, Bob, we'll go back to you. This is John Mungai. Hi, John, from East Africa, Kenya, the father of forensics in East Africa. Touching on what Laura said, and I think it actually is a very good question, what are possible methods of extracting DNA from formalin-fixed tissue?
I'm just wary of time, and I'm very happy to discuss that with him as well. But in brief, you first have to undo the formalin fixing and the paraffin embedding. And so depends how that method, it depends how the tissue was prepared. It's often with dehydrating the tissue with different concentrations of ethanol, and you reverse that to hydrate the tissue. You can also deparaffinize the tissue using many different methods have been explored. There's no real consensus on the best way. And then you follow kind of a similar process to hard tissue where you would incubate that tissue overnight to try and lyse the cells and then you purify it on day 2. But I'm very happy to go into the technicals in maybe a different forum.
Thank you. Maybe what we can do at the end of the panel discussion is share some research and yeah, absolutely. Bob, may we have your question that you want to address to the panel behind you?
Good morning, everyone. Robert Green from the UK, from the University of Kent at the UK. The question is, as the newer DNA multiplexers have become more and more sensitive, have you found that to be a double-edged sword in the same way that we have in the UK, where the new multiplexers are optimized to work at around about 500 picograms, which effectively on the one hand is great for recovery, but on the other hand is difficult for interpretation? Is that something that's crossed the continents?
So I would say before implementing any protocol in the lab, and this is, I would say, and the reason why we have ISO certification is to make sure that everything is standardized, answering to the training board. It also ensures that all our staff are competent to perform the test, to go to the court of laws, and also with regards to the amount of DNA that is required for getting a proper profile. This also we do internal validation, because at times commercial kit might say we need 5 nanogram, but we can have full DNA profile with 1 single hair or epithelial cells also. So this is very important to ensure that the laboratory parameters are as required, but then we do validation based on serial dilution, depending on the known concentration, or at times it might be unknown concentration, just to see to what limit of detection. Is it nanogram, or can we go down to picograms also for analysis? And especially with the kits that are being optimized with regards to elimination of PCR inhibitors and everything, it is also important to know that at times in commercial kits, they tell that we need to have 3 washes, but if you do your internal validation, you will see that you can reduce the amount of buffer that you need to wash. Because if we could talk of touch DNA, the origin is that it is scarce, it is very limited. So we've done internal validation in Mauritius to see if we really need 600 microliters of the buffer, or we can reduce that. So it depends all on the internal validation proposals and of the lab, and when it is properly validated and implemented.
Thank you. Do you want to add anybody to that?
Yeah, okay, to the double-edged sword and sensitivity. Scientists, we like to build better mousetraps. And once you build a better mousetrap, you now have something to do, so you build a better mouse that can evade the trap, and then you build another one. And this is sort of the way this is going, in the sense that it's not so much a double-edged sword, it just creates new challenges. So when we started DNA typing, we needed to stain about 2.5 centimeters wide or something like that to get a result. Contamination in the lab was not an issue. As we got more sensitive, we had to now improve our way we handle evidence and how much cleaner we had to be. So we developed better processes. So went on now to original samples, 1 or 2 person mixtures. You didn't see much else, but now that you're swabbing tables and doorknobs and whatever else, you're starting to see 4 or 5 person mixtures. That at the same time fostered innovation. So now we have probabilistic genotyping to assess mixtures. So instead of saying yes, it creates more challenges, but it also creates this incentive to come out with better ways to do what we do, to make us better, to better quality. And we even had the question of quality management. That evolved a lot because of DNA and a lot of things, and the kind of challenges it put in place that is now spread out across the other disciplines. So those challenges to become better because of the greater sensitivities, greater resolution, have benefited all of us and continue to do so. So I would put it again, better mousetrap, better mousetrap. Yeah.
Love your analogies, Bruce. There's a question here from the online audience, and it's something that comes up often. I know we've spoken about it too with the panelists. Optimization from protocols requires research. Any chance to establish a research facility, excuse me, by SAPS to deal with such samples together with regulations? And I'm sure that there are other laboratories in Africa that, you know, if you think about the casework that we have and that you're working with, it's crazy that we don't have more publications, that we don't have more support for research. So I wonder if you could just briefly tap on, you know, how you can progress that and how we can better make use of a research facility attached to the actual working laboratories.
If I start,
Yes.
in our from Bureau of Forensic Science in Somalia, we have a highly trained scientists, so they wish to do research, but unfortunately the workload and the limited number of instruments we have won't allow you to do that. So having a facility separate from the investigative part, it will be good and something to be actually invested in, because you have a highly trained scientists who also do practical work. So yeah, it goes without saying that you need to do the research as well.
I spoke about this at the first symposium, but I know you weren't all there. Was a collaboration with forensic institutes and universities. And the model is not a new one because medical schools and hospitals collaborate in such a same way of doing teaching, research, and service delivery. And I think, you know, given that the instruments are being fully used for casework, partnering with the amazing universities in your cities and working together to address relevant problems, you can do that optimization through that collaboration.
I would just like to add to what Professor Bruce mentioned previously. It's about to tap within Africa, sharing the best practices that we have, create a platform where forensic practitioners can share what they have done, what are their challenges, so that we are each able to contribute to the progress of forensic in Africa.
Any questions from oh, Bruce, do you want to add to that? Sorry. No? No. Questions? I saw there was somebody else. Did anyone else want a question from the audience? I have another question here, and again, it's around capacity building. This is from Ghana, Lawrence. Hi, Lawrence. Thank you to this event. Absolutely. My concern is DNA analysis is such a good tool, which we all agree that it's not the only evidence, but it certainly is. In terms of evidential value, it really is a valuable form of evidence. The cost is scaring us most, okay? From low middle income countries and trying to achieve our goals with respect to forensic investigations, is there any hope? Of course there's hope, but how, I mean, have you got any, I mean, Mauritius, I mean, we know that you really are going to be hearing from Asher in terms of their progress and advancements with their laboratory, and we've heard from Somalia, they've done it. But, you know, for countries that really have nothing, they want to build their DNA capacity in order to, you know, be able to look at highly degraded samples and challenging samples. Can you, maybe each of you, just from your own experiences, give some word of advice as to where do you start, you know?
Okay, so firstly, I would say there need to be a team of dedicated people who really believe in forensic DNA. And the most challenging part is to make administrative sectors know about the importance of forensic DNA. So the first thing is to bring the the tip of the iceberg, the outcome of collaboration, implementation, education, as the
system because some failure. DNA not particularly
right? And you always look at the relative of, Yasin's got a lab now, he has to manage this, and he's got a budget. So what can I do when I fit it into my current budget? The reality is the amount of money that you're spending in, let's say, DNA is really very small to the benefit it has to society. And that can be many, many rands, dollars, pounds, whatever the currency is. If you figure out how this investment gives a larger benefit and gain over here. So I've just done some analyses, whether it was from swabs or sequence or whatever. We have data in the US that says if a woman is raped, there's this much medical cost. And it's an average number, higher or lower for each one. There's this much for adjudication, this much for investigation, this much lost on productivity, this much lost on quality of life. Those have values. And to people who give funding, they understand, hopefully they are supporting you as society, victims, and safety and security. But the reality is they look at dollars, rands, whatever, the cost. And so if you can do your homework and say, if I do this, you invest this much, you'll get 5-fold saving over here. And it's a very simple thing to do. You just have to get the data to do that. So when you go forward to the different groups, I mean, I can tell you, I just did an exercise where we could reduce the number of victims in the US per year by 50,000 victims. That's a huge impact. And the dollars that go with that save billions of dollars in US money. Given that information, politicians, they understand that. And so you can give them something that they latch onto, although you would like them to think that, safety and security and protection are the main issues, it really comes down to funding. And so what are you going to convince them is that why putting more money into my lab is beneficial. And I think you have to do the homework to show what the real tangible and intangible benefits are, get it documented and bring that forward, because that will get the best traction for getting the resources that you need. Because you're not going to change the cost of kits, because it's not the kit that's changing in price, it's the distributors and others in the process that are putting these costs on, and it's the import taxes.
Yeah.
If you had the government say we're not going to tax these kits because they're for this purpose, you could reduce your cost a lot, but the government's not going to do that either. So it's not so much just the companies costing, it's the process that's costing. So you really have to embrace what it is and show the benefit that you get by making this small nominal benefit investment for this big gain.
Excellent. Sad?
Just lastly, I'm very fortunate to be at the Cape Town lab, but yes, the South African rand exchange rate versus the dollar. You can, Bruce, Bruce is going to give me
Yeah,
two
200 Rand, Bruce.
So yeah, on the one hand, this is also why it's so extremely expensive. It's because our own rand is so weak. But the problem that I have, and I don't know how many of the suppliers are actually, and I also don't know whether they have control over it, is the expiry dates. Even the plastics have an expiry date. We can understand that reagents, they are obviously manufactured in bulk. They are shipped in bulk, but by the time they get to us, it's so close to the expiry date, and that applies even more pressure on us to be able to finish in time. Or give on the certificate of analysis, give us some proof or statement that even though the expiry date is 13 of June 2023, you will still be able it will still be viable.
Yeah,
They will
great
still
point.
guarantee the results for next 6 weeks, 2 months. So yeah, from my side, because that has a huge impact on our reduction.
Those are great points, and I think that it's a great way to wrap up because it's time for tea. But I know that there's also quite a few publications on this subject specifically, and I think what we'll do is we'll have a page on our website where we will add these resources that you can tap into. And if anyone from both the live and the online audience has a publication that you think would be relevant to this particular panel discussion, please email us admin@dnaforafrica.com and we can start to add it, because this is when we talk about shared best practices and collaboration, this is what it's all about. And we can just from this short discussion, you can see how much we can learn from each other. Thank you so much. We could go on all day, but you guys are unbelievable. And I'm sure let's give them a big round of applause. It's been so informative, and we really value your expertise and your willingness to share it with us and with everybody else. So please enjoy tea. We'll be back here and start at 11 o'clock sharp, and look forward to the next session. Thanks so much.